Today I'm going to be explaining a new advancement in nanotechnology, and this new advancement is commonly known as nanodiscs. So, what is nanotechnology? Nanotechnology is the study of things measurable by nanometers. I like to think of this as anything that fits into a sphere that measures 100 nanometers in diameter, but is of course measurable by at least 1 nanometer. So what are some applications of nanotechnology? Recent science has been able to apply nanotechnology to energy, nutrition, construction, chemical weaponry, pharmacy, and much, much more. Nanodiscs are a recent advancement in pharmacy in terms of drug packaging and specific tissue delivery. Many of the issues pharmaceutical companies have to overcome are adverse effects, and this is because of drugs acting on tissues that are not intended. Nanodiscs can target specific tissues and reduce the amount of adverse effects on drugs. So, what are nanodiscs? Nanodiscs are particles similar to high-density lipoprotein that are already found in the body that condense typically hydrophobic compounds. High-density lipoprotein attracts and removes lipids from the blood. It is made up of apolipoprotein belts that secure hydrophobic lipids, and it collects these lipids in layers. Here, I've drawn a quick sketch about what HDL would look like in the body. Here you can see the apolipoprotein belts condensing and collecting various lipids that it comes in contact with. Similarly, nanodiscs utilize the apolipoprotein belts, and it is made up of primarily phospholipids. Nanodiscs typically lack the layers and mass of HDL as a bilayer disc. What I mean by that is that HDL is comprised of phospholipids, it is comprised of triglycerides, and cholesterol. Nanodiscs, on the other hand, only use the apolipoprotein belt and the phospholipids to make up its body and structure, rather than having this clumpy mess that has to be removed from the body. So, moving on to the structure of a nanodisc. On the left here, you can see a diagram of a nanodisc in its basic form. Here on top is the nanodisc by itself, along with its main component, the phospholipid. Here you can see the apolipoprotein belt that secures all of the phospholipids. The apolipoprotein belt does this by acting on the hydrophobic and hydrophilic properties of phospholipids. The tails of phospholipids are hydrophobic, whereas the heads of the phospholipids are hydrophilic, meaning that when a cluster of these are dropped into a solution that is water-based, the tails will like to cluster together, hiding from the water while exposing the head to the water. And this happens to form a cell-like membrane, similar to the ones found and welcomed to the body. So to treat disease, we can attach these lipids to various ligands or other pharmaceutical compounds that would help deliver a drug effect. And when these compounds or ligands are attached to these lipids, they will cluster with the other lipids, making a biological compound that happens to be attached to a drug, which is easily administered to the body and can easily access cells throughout the body to deliver the drug effect. So, how do we create these interesting particles? Well, first, the lipids and other components are all suspended together, meaning the phospholipids, the apolipoprotein belts, and any pharmaceutical compounds that are being attached to the phospholipids are all suspended together in a water-based solution. Then all the components are exposed to cholate, which is a chemical that makes particles more soluble in water or makes hydrophobic particles a little bit more hydrophilic for a period of time. Then the cholate is removed through dialysis, and from here the mixture is ready to be turned into nanodiscs. So the mixture is first incubated, which excites the particles. It creates more activity in the mixture and allows all of the phospholipids to be trapped inside of the apolipoprotein belt. And here we have essentially ugly nanodiscs. The nanodiscs will be falling apart, they will be moving around, they will just be very unorganized. But when the mixture is refrigerated, the structure becomes far more refined and more clean and more structurally sound to be acted on by the body and being exposed to the environments that the body will present. So here, I will run an animation of the formation of nanodiscs. Thank you for viewing my submission. I hope you have learned something about the fascinating nanodiscs. This has been Isaiah Henry from New Britain High School.